In this video, we're going to talk about the structure of the Earth's atmosphere, and we're also going to talk about the temperature profile that is observed in the Earth's atmosphere. So starting from the bottom and working our way to the top, you see that we start off here in the troposphere. Now, the troposphere we're going to be talking about for 99% of the semester. This is because this is the layer of the atmosphere in which we all live, and it is the only layer of the atmosphere for which weather occurs. So we're primarily going to be talking about the troposphere. After the troposphere, the next layer, as you go higher up in altitude, the next layer is what we call the stratosphere. You go up the next layer, higher up in the atmosphere, and you have the mesosphere, followed by the thermosphere. So those are the four layers of the atmosphere. TSMT is how I remember them. And what's interesting to know about these four layers is how temperature varies between them as you go higher up in altitude. So you see here in this graph, on the left-hand side, on the y-axis, we have height in either kilometers or miles. And then at the bottom, along the x-axis, we have temperature. And as you go towards the right, temperature warms. As you go towards the left, temperature cools. So in looking at the temperature profile for the Earth's atmosphere, we notice that in the troposphere, the higher you go in altitude, or as we say in the weather world, the higher you go in height, temperature decreases. You can see this red line indicates the temperature profile. And as you can see, as you go higher, temperature actually decreases. So you can also say that if you start up right around Mount Everest, which would be the top of the troposphere, or anywhere that is high above the surface of the Earth, as you get closer to the surface of the Earth, temperature actually warms. So you can look at it both ways. So why is it that temperature actually decreases as we go higher up in the atmosphere? Well, for number one, all of the Earth's energy is given by the sun. So solar radiation comes in and heats the surface of the Earth. The air is actually transparent to all incoming solar radiation. So what does that mean? So that means that the sun's rays do not actually warm the air by itself. The sun's rays will actually pass through all air molecules and will simply just go right through them. They don't necessarily warm. But the surface of the Earth warms. We have blacktop, we have pieces of the Earth that actually will absorb solar radiation. So that solar radiation that gets absorbed at the surface, it heats the surface of the Earth. The air that is right above the surface of the Earth actually will warm due to its close contact. We call this conduction. So if you think about conduction as if you ever have touched a hot pan before, that is the heat that is coming from the stove transferring to the pan. You touch the hot pan, you get burned, and the heat that is exchanged between you and the pan is due by conduction. So it's the same method or the same idea in our atmosphere that the Earth warms by conduction, or the air right above the surface of the Earth warms by conduction. So it makes sense that the further away that we get from the surface of the Earth, the colder it gets. But then what happens in the stratosphere? Well, between the troposphere and the stratosphere, we have this little layer. It's called the tropopause. Now, the tropopause also is, you can think of it as like a little boundary layer, or a little transition layer between the stratosphere and the troposphere. So you actually noticed here that in the stratosphere, temperature warms again. Now, why is that? Now, there's no land here, or there's no, there's no ground here for the sun's rays to warm up. So why does temperature actually increase here? Well, temperature increases here because this is the layer of the atmosphere that contains the Earth's natural ozone. And ozone is very important because it absorbs all the harmful solar radiation that the Earth would receive. So without it, humans would actually be in contact, or really all living things would be in contact with more harmful solar radiation. So you can think of the ozone layer in the stratosphere as being the Earth's natural sunblock. So it makes sense that if ozone is absorbing all of that harmful solar radiation, that it is actually warming in this layer. And so that is why temperature actually increases as you go higher in the stratosphere. But then you get to the next layer of the atmosphere, and this is the mesosphere, and there isn't really anything here, and so that's why temperature therefore decreases again in the mesosphere. And then as you get to the thermosphere, you notice that temperature once again increases. So why is that? So what's special about the thermosphere? Well, to keep things really simple, the reason why temperature increases in the thermosphere is simply because the sun's energy is very close to this layer of the atmosphere. This is the top layer of the atmosphere. So it is closest to the sun. It is closest to getting that incoming solar radiation since it is at the top of the atmosphere. And that is why temperature therefore increases again. So this is the 4 layers of the atmosphere, and this is why temperature varies between them.